All right, in this video, we're going to look at a concept summary for odd and even functions, just as an introduction to section 3.7. So odd and even functions, a polynomial function, and then in this case, we have p of x, is an even function. This is what we're looking for if it is symmetric about the y-axis. So remember, even would be symmetric about the y-axis, and then an odd function is symmetric about the origin. All right, so I have a couple examples here. I just want to go through the graphs and explain how to tell based on the graph whether it's even or odd. And then there's just a little note here about other types of functions can also be classified as odd or even. Uh, that should just say 4. The function y equals the absolute value of x is an even function. When you get into graphing absolute values of absolute value of functions, you'll see what's going on there. But we're not going to worry about that in this example. So looking at this even function, we're talking up here if it is symmetric about the y-axis. So basically what's happening is if I cut this graph in half, right along the y-axis, my left and right side should be exactly the same. And if I pick any point, so let's say this point here, the distance to that y-axis should be the same as this equivalent point here. Okay, they're symmetrical. So same distance. If I pick a point down here, the distance here should be the same as the distance there. All right, now how can we use that, or what can we kind of look at? Let's look at this point on the right here. Let's say that this is just our value, something of x, right? Our x value would be positive, and then the y value would be a function of that x value. Whereas if I do the same thing on the left, this, whatever this x is, we know it's going to be negative because it's left of the y-axis. So this is negative x, and then my y value will be a function of that negative x value. And ultimately what's happening is if we look at these two here, they're going to be the same. All right, the y value is equivalent, because again, they're kind of mirrored over across the y-axis. So in this case, you're looking at like, that's about 2.5 or so. All right, we're not going to go into specifics, but that is true for all of your x's in your domains. No matter what point I go along this left side here, my y values, if I just mirror across, are all going to be the same along that function. So just kind of keep that in mind. That's really all you're looking for. Let me just erase those. Even functions, your f of x is equal to f of negative x. Now let's look at the odd functions. Odd functions we set up here. We're symmetric about the origin. So really, one of the easiest ways to test for this is you want to kind of rotate your graph 180 degrees. All right, you want to see if it's the same. So I'm going to change colors here. And what I'm going to do is I'm going to trace this graph right here as closely as I can. Let's get rid of this little arrow. And now if I was to take this piece here, and if I rotate it 180 degrees, I have the exact same graph. All right, it hasn't changed. It kind of, you will say it reflects itself, it covers itself. So again, if this gets rotated 180 degrees, it's the same graph. So that's how we can tell whether or not it is an odd function. And now the odd functions, let's pick a number here. This looks like 1, 1. So this one here, this would be, right, x of f of x, a function of x. And then same thing down here, we have this point. This would be our negative x value, and that would be a function of negative x. And then we have this statement here. All right, for all x in the domain, for odd functions, f of negative x will be equal to negative f of x. And you'll see how that plays out a little bit more as we go through some examples in this section. And then finally, there's just a graph here of an example of neither case. If I was to cut this in half along the y-axis, we clearly see that the left side and the right side are not mirror images of one another. And then if I was to try and take this here, and then if I rotate that 180 degrees, that's obviously not the same graph. So not every graph is odd or even. There can be neither, and just kind of keep that in mind when you're going through section 3.7. All right, so go to the next video and we'll go over example 1, identifying based on the graphs.